Hey guys, this is Johnny, and in this video we're gonna move the player with WASD keys and make sure the player rotates smoothly towards any direction. Before we go into the code, let me show you how the design works. Assume this is the player. We're gonna need a direction vector which is going to change with the input. This vector is going to determine where our player intends to go and also where the player intends to look. I'm saying intends to because the player is not going to change his velocity and its rotation towards the direction instantaneously, but rather smoothly with some acceleration. We're gonna need a velocity vector which is going to be the actual velocity of our player. This vector is going to lerp towards the direction vector. Also, we're not going to rotate the player object, but rather we're going to rotate the mesh node smoothly towards the direction. The mesh node contains the player 3D model. We're also going to need a variable for acceleration of the velocity, and also an angular acceleration for the smooth rotation of the mesh node. So first I'm going to go to the input map and add 5 inputs, WASD for forward, left, backward and right, and space for sprint. I'm also going to create a new node called status and add some color rectangles with keyboard key names with labels on them. I'm going to add a script to our player, and in the input method I check for the keyboard keys. If any of these keys are pressed, it sets the color of the rectangle red, and if it's not pressed, which means released, it becomes white. This way I can visually show you which keys are being pressed. I'm going to create a direction vector. The X value is the action strength of the left key minus the action strength of the right key. Whenever we press a key, its action strength becomes 1. So if we are pressing right, the X is going to be -1, and if we press left, the X is going to be +1. If you notice here, going towards the red arrow means positive X and the other way is negative X. The Y value of the direction would be 0, and for the Z value, I'm going to do exactly what I did for the X value, but with forward and backward inputs. Now I'm going to call the move and slide method, which takes a vector3 parameter, which determines where the player is going to move. And the second parameter is the up vector. I'm also going to create 2 labels to see the values of the direction and the length of the direction vector. So if I run this, you can see the players going towards the direction. But the direction is not relative to the camera, meaning the forward direction is not where the camera is looking, but it's the global forward vector. There are multiple ways to fix this. I prefer to rotate the direction vector with the H node from the camera. If you watched the previous video, this H node rotates on its y-axis according to the horizontal movement of the mouse. I'm going to create a variable hrod and assign the y rotation of this H node. The global transform basis get Euler returns the global rotation of this node. And we're going to use the rotated method for the direction using upwards vector and the hrod. This rotates the vector around this axis with the value of this. Now our player is going where we want. But you can see the length of the direction vector is not always the same. If we go forward, backward, right or left, the length is 1. But if we go diagonally, it's more than 1. That's because when we go diagonally, the X and Z both have the magnitude of 1. So following the Pythagorean theorem, the length of the vector is the square root of 1 square plus 1 square, which is this value right here. To fix this, we simply make the direction normalized. What normalized does is, it divides itself with its own magnitude. So the result is a vector with the magnitude of 1 with the same direction. So if I run it now, you can see the speed is the same in every direction. So now I'm going to create a movement speed, walk speed and run speed. When any of these keys are pressed, if sprint is also being pressed, the movement speed is going to be run speed. Else is going to be walk speed. And if none of these are pressed, the movement speed is going to be 0. I'm going to multiply the movement speed with the direction over here. I'm going to set the walk speed as 1.5 and the run speed as 5. So if I run this, you can see that if I press the space key, the player moves faster, and without pressing it, makes the player go slower. Now I'm going to create a velocity vector which will be a vector 0 initially, and I'm going to lerp the velocity from itself to the direction multiplied by movement speed. We also need an acceleration which will be multiplied by delta. I'm also going to replace this with velocity. I'm going to add a vertical velocity and a gravity variable, both of which are going to be floating point numbers. If the player is not on floor, I'm going to add gravity times delta with the vertical velocity, else the vertical velocity is going to be 0. I'm also going to add a down vector here and multiply it with vertical velocity. This here is going to simulate gravity. I'm also going to add 2 more labels here where I'm going to show you the velocity and the velocity length. So if I run this, you can see the movement is pretty smooth. So now I'm going to rotate the mesh node towards the direction the player is going. I'm going to use the lerp angle method to change the rotation smoothly. This is similar to the lerp method, but it wraps up the angle so that we get our desired rotation. I made a small demo to show 3 ways to do 3D rotation, and I'm going to link this over here. For the target angle, I'm going to get the angle from the direction vector using the 8 and 2 method. What 8 and 2 does is it takes 2 coordinates of a 2D vector and returns the angle of the vector ray from the positive x-axis. For the weight, I'm going to create a new variable called angular acceleration and multiply it with delta. You can see the player is rotating smoothly towards the direction. But if I release the movement keys, the player rotation resets back to 0. To fix this, I'm just going to drag this inside this block. So now, it works perfectly. I made the angular acceleration slightly bigger than the acceleration so that the player rotates towards the direction slightly before moving towards that direction. If I make the acceleration too small, then it looks like the player's running on a slippery surface. You can play around more with the values. So that's it for this video. In the next video, I'm going to blend the animations with the movement of the player. So see you in the next one.